𝐈WIN makes both you and your child happy for life. 𝐈WIN is to win. Give your child the 𝐈WIN advantage now.
Hello students, here in this class I am going to explain one of the problem from the laws of motion, and the question is a previous competitive examination question, and the question is this one. What is the question? A block of mass 5 kg is placed at rest on a table of rough surface. Table is of rough surface. Now a force of 30 Newton is applied in a direction parallel to the surface of the table. Parallel to the surface of the table, a force of 30 Newton is applied. The block slides through a distance of 50 meters in an interval of time 10 seconds. The quotient of kinetic friction is, so the question is find the quotient of kinetic friction. Given that the acceleration due to gravity g as 10 meters per second square. Now the options. First option is 0.6. Second option is 0.25, third option is 0.75, and the fourth option is 0.5. Now, this question was appeared in 1st February 2023, shift 1 in JEE mains. And now go to solution. So here, before going to solve this problem, what are the data that is given in the problem? Here, once you observe, mass is given 5 kg, right? And next, applied force 30 Newton parallel to the surface. And the next one is distance traveled by the block, 50 meters. Here it is. And the time interval is 10 seconds. And G value is 10 meters per second square. These are the given data. First, I am writing given data. So what given? Mass is 5 kg and applied force is 30 Newton. Distance traveled is taken as S, which is 50 meters. And G is 10 meters per second square. Similarly, time is also given. What is the time? That is 10 seconds. That is the time. Now, here, what concept involved in the problem? So here, on a rough surface, object is placed like this. This is the block of mass 5 kg, which is kept on a rough horizontal surface, having quotient of friction, mu. That mu is question mark here, right? So, and parallel to the surface, a force of 30 Newton is applied. Now, we are going to calculate mu. To calculate mu, before that, it is under motion. So, there is some acceleration for this object. That acceleration is A. So, first, we need to calculate that acceleration. So, to calculate that acceleration, here, first, we are using the formula S equal to ut plus half at square. Why? Because distance is there. Start at rest. At rest means what is initial velocity, which is 0. Initial velocity is 0 meter per second. Initial velocity 0. Time 10 seconds. Distance traveled is 50 meters. So what the kinematic equation which relates these? That is S equal to ut plus half at square. Then we substitute the values. What are the values? Yes, 50 meters is equal to U is 0. 0 into time is 10 seconds, right? Plus half A into T square, 10 square. So this one. So in the next step, this is the next step. What is here? 50 equal to 0 into 10, 0 plus half A into 10 square is 100. Here 2 times means here 2, 50 times. This 50 here cancel. That means what is the A value? We find the value of A is 1 meter per second square. This is acceleration. Now, here along the vertical direction, there is no displacement in the body, right? So that means along the vertical direction, if you apply NLM, equilibrium condition, upward acting is normal reaction, downward acting is mg. That means N is balances with mg. So what is N value here? N is mg. M is given as 5 kg, G is 10. That means normal reaction value in this block, acting on that block is N equal to 50 Newton. Now, here along the horizontal direction, it has certain acceleration A. That means sigma F along which direction? X. Means again we are applying second law, Newton's second law, which is equal to ma, mass of the object into acceleration. For this, we apply equilibrium condition along this direction, horizontal direction. That is sigma Fx equal to max. What is ax? Ax is the acceleration along the horizontal direction. Already I derived that value. Ax equal to acceleration along the horizontal direction is 1 meter per second square, right? So that is. So now observe here, along the acceleration direction, 30 Newton force is acting. Opposite to force applied, opposite to the applied force, frictional force is acting. Frictional force, F formula is mu into N. But N is equal to mg. So that means frictional force F equal to mu mg. Now along this direction F, along this direction frictional force. This is the direction of frictional force. Then capital F minus small f equal to mass of the body into acceleration along that direction. What is capital F value? 30 Newton. Minus small f, mu into n. What is mu value? I don't know. I need to calculate mu into n. Normal reaction, nothing but mg. Mg is what? 5 into 10, which is 50. That means frictional force is what? Mu into 50, which is equal to mass of the object 5 into its acceleration is 1. Now 30. Bring this 5 into 1, 5 to this side becomes minus 5 is equal to mu into 50. 30 minus 5, what that value? That is 25, right? 25 equal to mu into 50, which implies mu equal to 25 by 50, which is equal to 1 by 2, which is nothing but 0.5. Quotient of friction, no unit. So just mu is equal to 0.5. Fourth option is correct, right? Now in the text form, we observe. Once again, I am repeating the solution. Given data is this one. First of all, we are finding the acceleration value by using s equal to ut plus half at square. Whatever the data is there, that data substituted in this formula, we derive the value of acceleration as 1 meter per second square. Next, Newton's second law is applied along the horizontal direction. The resultant force is equal to m into a. A is the acceleration along that direction. X direction, that's why ax we are using. So along this direction, 30 Newton, opposite to that, mu into mg is equal to ma. So 30 minus mu into mg is what? 5 into 10, that is 50, is equal to 5 into 1. Mu into 50 equal to 25, which implies mu is equal to 0.5. Correct option is fourth option. Thank you.